This week we're going to be talking about solving exponential and logarithmic equations, okay? There are two basic strategies for solving exponential or logarithmic equations. Now, I'm going to tell you that exponential equations, I kind of go along with that, but logarithmic equations, I don't agree with that. I think there's only basically one way to solve a logarithmic equation. I suppose there are two, but I usually just stick with one method. The one-to-one property for exponents tells us that if you have the same base, that your exponents have to be equal, right? So if I had, like, for example, if I had something like 2 to the, whoops, I gotta turn my marker on here, 2 to the third is equal to, what is that, 8? If I rewrote 8 as 2 to the x power, and I wanted to solve that, well, if the bases are the same, we know the exponents have to be equal. Okay, so the bases are the same, the exponents have to be equal, so 3 is equal to x, x would equal 3. Same thing with logarithms. If you have a log, and I suppose this is a one-to-one property, so this is one way to solve a log that I never even thought about. If the logs have the same base, okay, you could just cross those off. Boom. You would just end up with 5x minus 1 is equal to x plus 7. So if you can ever rewrite, but it only works if you have one log on one side and one log on the other side. If you had something else on here, if you had, plus 5, this does not work. It is when you only have the log on one side and the log on the other side there, it's the same base, you can cross off the logs. Okay, that's the one-to-one property. So that's one way of solving exponents and logarithms. So if I gave you a problem like this, if I said 1/5 to the x is equal to 125, solve for x. You can use the one-to-one property. Now, some kids would have a difficult time doing this because they would, oops, sorry about that, I got to turn this off here. Okay, they would have a difficult time trying to get the bases to be the same. Well, I would just bring 125 over here and I say, okay, 125 is the same thing as 5 to the third, isn't it? Okay, if you answered yes, then yeah. Then how about if we can we rewrite this as 1 over 5 to negative third? Is that the same thing when you think about it? So couldn't I rewrite 1/5 to negative third? Isn't that 125? Because if you take it backwards, let's just take this backwards. If I have 1/5 to negative third, well, first thing I would do, since it's a negative exponent, I'd flip it over, so that would be 5 to the third. Well, 5 to the third is 125. So this is the same thing as 125. So 1/5 to the x is equal to 1/5 to negative third. Now I have same bases. Exponents are equal. X equals negative 3. Boom, done. That's one way of solving an exponent. Get the bases to be the same. Now, you can't always do that. I mean, that only works some of the times, because if I gave you something like 2 to the x is equal to 5, and I want you to solve for x, there's no way you're going to rewrite 2 and 5 with the same base. So there has to be a different way of solving that type of problem. And there is. And the way I always do it is I always look at it and say, okay, if it's an exponent, I'm going to rewrite it as a logarithm. So I would rewrite this as the log base 2 of 5 is equal to x. Well, guess what? We learned how to solve problems that don't have common, or problems like this. You use a change of base formula, or some of you have calculators that do this, or you go to Desmos. So log base 2 of 5. I'm just going to jump to my Desmos calculator. I'm not going to, I'm just going to type this in. So log base 2, I was working with trig functions before. So let me get that again. So log base 2 of 5 would be equal to 2.32. 2.32. So 2 to the 2.32 power should equal 5. And if you plug this in, it should work. So that's the second way that we solve exponent problems. First way is if you can rewrite it with common bases, awesome, then the exponents are equal. Second way is you just rewrite it as a logarithm and solve. Okay, so solving exponential equations. Step one, type 1, when the bases are both terms, when the bases are of both terms are the same, then we just set the exponents equal. And if they're different, what we're going to do is we're going to rewrite it as a logarithm. So strategies: rewrite the original equation in form that allows you to use one-to-one property if you can. Most times you cannot. Rewrite the exponential equation as a logarithm, or if it's a logarithm, rewrite it as an exponent. Okay, those are the ways that I solve exponential and logarithmic equations. First of all, I see if I can rewrite them with common bases. If I can't, then I just rewrite. Then if it's an exponential function, I rewrite it as a logarithm, try to solve. If it's a logarithmic equation, I solve it, or I rewrite it as an exponential equation. So let's try some examples to show you what I'm talking about. So I'm going to solve 2 to the x is equal to 30. There's no way I'm going to rewrite 30, 2 to some power is 30. It doesn't work. So what I'm going to do is I'm going to just rewrite this. And to tell you the truth, I always try to see in my head what my answer is going to be about. So I look at this and I say, okay, 2 to the 3rd is equal to 8. 2 to the 4th is equal to 16. 2 to the 5th is equal to 32. Oh, I know it has to be between 4 and 5, right? Because 2 to some power is equal to 30. So I'm just going to estimate. I'm going to say 4.8. I don't know what the real answer is, but I'm just going to say that. All right. So it's an exponential function. I'm going to rewrite it as a logarithm. So this is going to be the log base 2 of 30 is equal to x. Oh, that looks to be pretty easy to solve. I'm just going to go to Desmos calculator or my calculator. I'm going to plug that in. So log base 2 of 30, I have to remember that. So when I jump over here, log base 2 of 30, and now you guys can't see this. I'm just doing it. And I get 4.906. 4.906. And that's my answer. Now my estimate, pretty close. I mean, I wouldn't say I'm too far off. So if you have an exponent, just rewrite it as a logarithm and try to solve. Here, there's no way I'm going to rewrite e and 9 as common bases. So I'm just going to rewrite this as a logarithm. So I've got the log base e of 9 is equal to 4 minus 4x. Now, that is, so log base e is really a natural log, right? So natural log of 9 is equal to 4 minus 4x. Well, I don't know what the natural log of 9 is, but I do have a calculator. So I'm jumping to my calculator again, and I'm just going to do natural log of 9, and that gives me 2.197. 2.197. 2.197. And now this really hard-looking problem just becomes an equation. I'm going to just subtract off 4 here. This is where now I'm going to get my calculator out. Just my regular cheapo one. 2.197 minus 4 gives me negative. So now I have negative 1.803 is equal to negative 4x. I'm going to divide through by negative 4. So divided by negative 4. And I come up with positive 0.4507. That's my answer. So if I have an exponential equation and I'm trying to solve it, I just rewrite it as a logarithmic equation. And then hopefully you should be able to find the value. All right, let's try another one. Oh my goodness. 4 to the 2x squared plus 2x is equal to 8. Now, this problem, I'll do it 2 different ways. First way I'm going to solve by just rewriting it as a logarithm, okay? So I've got log base 4 of 8 is equal to 2x squared plus 2x. Okay, log base 4 of 8 is, okay, so I'm going to go back to Desmos. I'm going to change log base 4 of 8. Oh no, that didn't work. Got to get rid of that. Okay, I'm using Desmos. I'm using Desmos, and they do have a function where you can put in any base you want, which is awesome. So it gives me 1.5. Okay, so this is 1.5 is equal to 2x squared plus 2x. I'm going to factor out a 2x here, just because I look at it and it's like, okay, oof, that is not going to work out nice. I'm going to, since it's a quadratic, I'm going to set it equal to 0, so I'm going to bring that over. So I end up with 0 is equal to 2x squared plus 2x minus 1.5. All right, that is not going to factor. Okay, so I would have to use the quadratic formula in order to solve, and I do not want to get into doing the quadratic formulas. So I am going to see if I can solve this a little bit easier. I'm going to see if I can solve it by using common bases. Okay, so 4, I can rewrite 4 as 2 to the second, can I? And 8 I can write as 2 to the third. So if I write 4 as 2 to the second, I still have this in there is equal to 2 to the third. So now I have common bases, so my exponents are equal. So I'm going to multiply through by the 2, so that gives me 4x squared plus 4x equals 3. I'm going to bring the 3 over, so 4x squared plus 4x minus 3 is equal to 0. All right, so now, again, I'm back to factoring. I'm not sure if this thing factors or not. Let me just check this out. So that's negative 12. Two numbers I multiply to give us negative 12 and add up to 6. That might work. Okay, so I'm going to factor that. 4x squared plus 4x minus 3. I'm going to try to factor it. I'm going to use the cheater method. So that gives me negative 12 up here. That's 6 and 2. So that gives me 2x plus 3. And, 2x minus 1. So my answer to this problem wouldn't be negative 3/2 and 1/2. Whew. That was a beastly of a problem. I would never give you guys anything like that. Holy moly, that is. But there's 2 different ways that you can solve it. You can solve it using logarithms. Now, if I continued with my logs down here, I could have solved it, but I probably would have had to use quadratic formula, because how do you factor negative 1.5? So that would have been pretty tough. Okay, so solving logarithms, basically the same thing. If you can get common bases, we do, and we get rid of them if you have the same logs on both sides. But if you can't, then what we're going to do is we're going to rewrite, and that's why last week we kind of combined like terms, or we condensed logs. Because now, if I have a problem like this, remember, if you have, I can't even read this number here. Let's go to another slide and see if they're better. Okay, so here, if I have the natural log of x equals 2, natural log, anytime I see that, I'm thinking log base e of x equals 2. I don't know how to. I don't know how to solve this, so I'm going to rewrite this logarithm as an exponent. So that would be e to the second is equal to x. Well, I don't know what e to the second is, but my calculator sure does. Jump in here. So 2.17 squared. So it's going to be like 4.7. So x equals 4.71. Here, I've got log base 3. I can cross those out. I'm just left with 5x minus 1 is equal to x plus 7. Now, this is just a regular equation. It's no longer an exponential or logarithmic equation, so I'm just going to solve it like a regular equation. So 4x minus 1 is equal to 7. Add that 1 over, so 4x equals 8, x equals 2. Now, could you check yourself? Sure. Put 2 back in here. 5 times 2 is 10, minus 1, that's log base 3 of 9. And if I put 2 in here, 2 plus 7 is 9. So I have log base 3 of 9 is equal to log base 3 of 9. Yeah, they're the same. Does work. Now, sometimes you're going to get logs like this, where you have more than one log on both sides. You can't cross them off then. You cannot just cross. The only time you can use that one-to-one property is if you have one log on both sides. So now I'm going to condense this. Remember, if you have a minus sign, I can rewrite this as a single log. Log base 6 of the 3x plus 14 over 5. Remember, if you have a minus, it's just divide, is equal to log base 6 of 2x. Now I have a single log on both sides, so I can cross them off. So now I'm left with 3x plus 14 over 5 is equal to 2x. Much easier problem than this. So I'm going to just cross multiply. 2x times 5 is 10x equals 3x plus 14. Subtract 3x off, I end up with 7x equals 14, x equals 2. Can I check myself? Sure. Put 2 in here. 3 times 2 is 6. That gives me 20. Minus, so log base 6 of 20 minus log base 6 of 5. Well, remember we divide, so that would give us log base, what is that, 4? So that would give us the 2x there. And then we can put the 2 in here. 2 times 2 is 4, so log of 4 is equal to log of 4. It does work. And we can check our answers. All right, solve the logarithmic equation. Well, there's no logs on both sides, so the first thing that goes through my head is rewrite this as an exponent. So this would be 3 to the 6th is equal to 8 minus x. I don't know what 3 to the 6th is. I'm sorry about that. So I'll get my trusty calculator. 3 raised to the 6th power is 729. So now I have 729 is equal to 8 minus x. I'm going to subtract 8 from both sides. So 721 is equal to negative x. So x equals negative 721. I would go with letter C. When we have applications, we're usually dealing with the PERT formula. PERT formula is, this is compounding continuously, okay? And this is when you can take and use your skills in solving to figure out the answer. So it says you invest $500 at an annual interest rate of 6.75% compounded continuously. How long will it take to double your money? Well, here's my equation set up, 500e to the point, because remember we have to change that to t, but in order to double means that it would be 1,000 here, wouldn't it? That would be 500 doubled. So I've got e to the 0.0675 t, and then I'm just going to solve this. I'm going to divide through by 500. So I get 2 is equal to e to the 0.0675 t. Well, guess what? This is an exponent. I'm going to rewrite it as a logarithm. Log base e of 2 is equal to 0.0675 t. This is natural log of 2 is equal to that. So I'm just going to, I think my next slide kind of goes through the rest of the solving it, so I won't. So basically, so I got there, rewrote it as a exponent. So natural log of 2 is equal to that, solve, and you get 10.27. So it would take 10.27 years for your money to double.